Hi, in this tutorial I want to go over some of the more advanced features that Solidworks surfacing has to offer. So we're going to go into a new part here, and I'm going to start a sketch here on the right plane. I'm going to drag out a 3-point arc, which we should be familiar with by now. And I'm going to right click on the arc and select midpoint, and click on the origin and make them coincident. I'm also going to select both of these points and make them horizontal. I'm going to exit the sketch, and I'm going to start one more sketch on the front plane. And on the front plane, I'm going to drag out a 3-point arc. It's going to come from the origin out. And I'm also going to drag out a for-construction line, which we can use to add tangency. I'm going to exit the sketch, and I'm going to start another plane with the curve being the first reference and this point being the second reference. And on this plane, I'm going to start a sketch for a 3-point arc, and I'm going to right click again, select midpoint, click on the origin, set them to be coincident with each other, and hit OK. From here, I'm going to click on these 2 points, and I'm going to make them vertical. So as you can see here, we have 2 profiles and a guide curve. But unlike in solid features like the lofted boss base or the swept boss base or even the boundary boss base, when it comes to surfacing, we can use open profiles to do lofts and boundary surfaces and etc. So I'm going to exit out of the sketch, and that's going to bring up some options here under the Surfaces tab. And so I'm going to choose to make a lofted surface. From here, I'm going to select this 3-point arc as my first profile and this 3-point arc as my second. For the guide curve, I'm going to select this arc I made. Let's look at this from the right. There are a couple options here for influencing the guide curve. The first one is to next guide. The second one is to next sharp, which, as you can see, changes it dramatically. The third one is to next edge, which doesn't have an effect, and the fourth one is global. And so each one of these is going to allow you to kind of stretch the surface in a different way. You also have your start and end constraints, which you can change. You can make direction vector or normal to profile. With normal to profile, you can actually change the angle at which the surface comes in to the first profile. But if you change this too much, you may stretch a material to a point where it can't be manufactured, or that it actually causes things to fail. But as you could see, I've stretched the material in this way just by changing the dimension here, normal to profile. I could also change the end constraint. I can do direction vector or normal to profile. If I make it normal to profile, then I can change the angle on this side. So I can manipulate the dimension, but also the angle. So if I bring this down, let's say 45 degrees, it's going to bulge out. So I'm going to take my shape here, which I'm manipulating, and I'm going to hit OK. And we're going to look at a couple other surface features I could use on this. So I can come up here to filled surface, and I can select this end, this top end, this other top end, and the first profile. And you're going to see that SolidWorks generates a surface based on the inputs I gave it. From here, I'm going to exit the filled surface, and I'm going to come up to Trim Surface, but first I need to create a profile on the front plane. So I'm going to start a sketch and create a rectangle here. And this rectangle can have a planar surface here by coming up to the planar surface tool. So that's just going to take a 2D shape, any 2D shape that's closed, and it's going to create a planar surface. Once I have that, then I can use the trim surface command. So I can select this as my trim tool, and I can either keep or remove a selection. So I can, for instance, remove this surface on this side. And so as you could see, part of the surface is lost. If I go back, I can select the other surface as well and completely delete it. And so from here, I can get rid of this surface plane by coming up to Insert and then Features, Delete Body. And once I do that, if you look closely, you can see I actually have an open side here. So I have this surface here, I have this surface here, but this is actually fully open. So the way to fix that is I need to create a planar surface or filled surface that can close this up. So I'm going to go up to planar surface and I'm going to see if this is going to work here. So planar surface works. But in instances where that doesn't work for you, you need to create a filled surface, which is selecting this and this, the outer lines, and that's going to create a fill-in for you. So I'm going to come up and create a planar surface. And at any point that you have surfaces that are all connected to each other, you can knit them all together. And so right now, if you look here on the left side in the feature tree, you have the 3 surface bodies, but there are no solid bodies here. In order to manufacture and make a part and a drawing and to do any of those things, you really need to have a solid. And that's where knit surface comes in. So I'm going to click on knit surface, and I'm going to select these 3 surfaces. And so once everything is selected, you come over here to try to form solid. And that's exactly what Solidworks is going to try to do. When I click OK, you can see on the left, the surface bodies have turned into a solid body. So if I go back and I just delete this, I'm going to show you another technique that you can use to create a solid from surfaces. The powerful part about surfaces is I can come up here and I can click on thicken. And if I select one of the faces, it's going to thicken that face. So I can come over here and hit OK. And as long as it's computable, the surface can be made. So I can come over here and hide the surfaces. And the only thing that really matters in SolidWorks and drawings in manufacturing are the solids. The surfaces are used to make solids, but the solids are what you're really going for. So I was able to create a very complex face very easily, very complex solid very easily by just thickening a surface. And you can do that with generally any surface you make as long as it's computable. So I can come back here and I could bump up the thickness and it's going to translate. I want to show 1 or 2 more tools here in the surfaces options that we can use. So I'm going to start on the front plane, a sketch, and it's just going to be a simple rectangle. And so I'm going to come back, exit the sketch, go to the Surfaces tab, and I'm going to click on Planar Surface. And if you click on Freeform, you can select this face that you've just created, and you can add curves. So I'm going to add these two curves, and I'm going to add points to those curves. And in a minute, you're going to see what this is going to do. So once I've created the curves, I can actually stretch the surface by hand amazingly. And so here it gives you the option of the dimension that you want to have for each of your triads in the X, Y, and Z direction. So I can manipulate this pretty much at my will, really in any direction I want. And so after I create a surface deviation, I can come in and hit OK, and as long as my surface is computable, I can come over here to thicken, and like we did before, click on the surface and thicken it. As I mentioned, as long as it's computable. So the surface needs to be thin or thick enough to actually be computed. You see, in this case, I had to select this option here to thicken downward because the upward thickness did not work. It seems to work at 1 millimeter, but when you bump it up too much, it can fail. And the reason why that happens is if you keep raising your thickness, you're eventually going to reach a point where your surfaces, they clash, they break into each other, as you could see in the preview. So if I bring that down, you're going to see that this is a healthy amount to thicken it, or at least it seems like it. You won't know until you actually hit OK, but it seems like a healthy amount. So this is around where the limit is. And as you can see, it did work this time. So I was able to compute that. And so think about all the modeling work that it would take to create this shape, when you can really just go in and do a freeform surface and create that form using a freeform surface. And so that pretty much covers it. This video is more of a rundown of the types of things that you can find in the Surfaces tab. There's obviously a lot more you can do, but I feel that when it comes to surfaces, the only way to really learn it is to do tutorials and practice it. Because I could show you all day little examples, but it's not until you really start working with it that you see the capability, but also the headaches that it could cause and how to avoid them. The one thing to note about surfaces is that any surface that you make needs to be knit at the end of the day. I mean, one of the only times where you're using a surface that isn't going to be knit into a solid is when you're using this tool here, Cut with Surface, which sounds what it is. You're creating a surface which is intersecting a solid and it's cutting that solid. But there are going to be most other times you're going to be creating a part or assembly that's using surfaces that needs to be knit.